Hello and welcome to another episode of Ken's Training. Today we are on a rooftop. We're going to work on this air handler number 5, which is directly behind me. It's December 18th, 2014. We're in Irvine, California. It's not a bad day out here. I am directly over the flight path of John Wayne, so every once in a while we got to cut the camera because too much noise from the airplanes. So the situation is that the engineer that's got this building, he's telling me, hey Ken, the supply fan that's behind this door is toast. We need to replace that supply fan. I say okay. So we're out here and the job today is to replace the 7.5 horsepower supply fan motor for air handler number 5. First thing I want to do, I come up here and the disconnect is in the down position. But even though that's down, I still don't trust it. I want to know what's up inside this disconnect. So I'm going to go ahead and open this up. And I want to see what's going on. Now, we'll give you a better visual of this, but I can physically see that the tongs of the disconnect switch, the knife blade switches that go like this, I can tell that they're all out. So I'm pretty much guaranteed that I'm safe. Another thing I'm going to do is just check with my meter. The middle button on my meter here is NCV, non-contact voltage. Push that in. And I actually don't even have incoming power, so he's got it shut off somewhere back further upstream. I just want to make sure that I'm safe working on this thing. Now, we're going to give you a close-up shot of those knife tongs. Alright, now here's a close-up switch of the disconnect switch. These are the knife switch blades right here. One, phase A, phase B. That one there is phase C. And they are controlled by this handle right here. Well, you can clearly see that they're all have disengaged from the point of contact. So I know that there's no way that I'm going to be transferring power from the top of the switch here. There's your conductors right there, brown, orange, and yellow, down to these conductors down here, brown, orange, and yellow. Anyway, so we're totally safe working on this thing with the disconnect in the down position. Now we're going to take a look inside the inside here. So here we are opening up the door. There's the motor that supposedly is toast. We're going to fully test that out. And then there's the supply fan shaft, the blower wheels, and everything like that. Alright, so here we are. It's my first time looking at this thing. The first thing I want to do is I just want to spin the shaft by hand. And this thing is 100% frozen. I mean frozen tight. Hang on, we got a plan. Okay, so this thing's frozen tight to the point where I can't even turn the shaft by hand. Now, that very well could be the motor, but there's also 2 bearings that are on the supply fan blower shaft that could be a problem. I want to absolutely confirm where my problem lies. The way to do that is I need to remove these belts. There are 3 V-belts attached to the pulley connecting the motor, transmitting the power to the supply fan shaft. So what I'm going to do is I'm going to loosen up the bolts that attach to the motor to the adjustable frame here, and then I'm going to loosen that up, remove the belts, and then figure out which one of these items is frozen solid. One thing that I've done, let me show you here how we got ourselves set up. Alright, so in order for us to work on this in an efficient manner, what I like to do is I like to just have a temporary workbench. So what I've purchased is I just purchased a couple of large trash receptacles that are on wheels, and then just put a piece of wood on top, and it's a mobile workbench. So we just put this in the back of the truck, load it up, load the trash barrels up with our tools, bring it up to the work site, empty out the tools, and now I've got a workbench to work on. And then I've got my toolbox over here with all my tools that I generally work with on a regular day-to-day basis. So that way it's just easy for us to have ourselves set up here to do this job. Alright, first thing I want to do is I got to start loosening up the bolts on the motor. Okay, so here's your motor, and this here is the frame that moves the motor back and forth to adjust belt tension with that nut right there. These are the bolts that actually attach it tight to this frame. So I had to figure out what my wrench sizes was. This particular wrench size here is, what the hell is it? It's 9/16 of an inch, okay? There's the close-up on that one. Alright, so that one's 9/16. And then I also need a wrench over here in order to adjust that one. And that wrench right there is 3/4 of an inch. So all I got to start doing is loosen up the 9/16 inch bolts. There's 4 of them. And then I can take this and bring this motor this way in an effort to get these belts over here nice and loose so that we can get those belts off the pulley. Okay, I got the 4 of them, the 4 bolts that I wanted loosened up. Then I took a black Sharpie, I put it along this line right here. Then I just take my 3/4 inch wrench and I'm just turning it this way here, which is clockwise, and I'm observing to see which way that line is going. And if you can see that, that line is moving in the direction that I want it to. So I'm bringing the motor this way, which is the direction I need to in order to loosen these up. So I'm just going to keep doing that until I can get the belts off. Alright, so I got the motor moved over this way a couple of inches. I got the belts loosened up here, okay? So I'm taking the belts off of the pulley. Hang on, some of them are still stuck. Okay. We'll check out these belts later, but the point is that I just wanted to get them off the shaft. Now that I got it off the shaft, now you can see I can easily spin the blower wheel shaft. So this is not my problem. Now I'm going to try to move the motor shaft. It is absolutely 100% frozen solid. So I agree with the first technician that said the motor was toast. The motor is toast. So I got the motor loose from here. I want to disconnect the electrical, and then once the electrical is out, I'll take these 4 bolts out and we'll pull this puppy right out. Okay, this is the motor electrical housing right here. Coming on in the unit, and just trying to get you the best vantage point here. I need to take this flat bladed screw here, turn that, and open it up. Righty tighty, lefty loosey. So just open that up, and basically we're just going to be looking at some wire nuts inside of here, figure out what we got, and then we'll just disconnect. There's going to be 3 leads that come in here, so we'll make sure that we figure out where the 3 leads are going to L1, L2, and L3, and then we'll just go ahead and pull this thing right out. One thing that I do is if the coloring is different, I'll just make sure that from the motor's terminals, if it's labeled L1 and that goes to the yellow, I'll put a number 1 on the yellow or make a note to myself, so that way I can keep the rotation on this 3-phase motor the same. Alright, so I observed the wires coming out, which are coming out right here, and then as an example here on the orange, if you can see that tag, this is from the factory motor. It's a little hard to read actually, but anyways, I wrote it down right here. So 1 is brown, 3 is yellow, and 2 is orange. So that way I can just keep the same orientation on the new motor. Hopefully they'll be similar. I don't know if it's the same manufacturer or not. Now there's also a ground lug solidly grounded to this box with the 5/16 inch hex. We'll loosen that up, put that on, we'll re-land that in the new electrical housing. Once all the electrical terminals are loose, all I got to do is take this lock nut here, loosen that up. I can pull my liquid tight flexible conduit out of the way, and the electrical at that point in time will be removed from the motor. So we're going to do that right now. Okay, all the electrical is to the side of the motor. The 4 bolts that hold the motor to the adjustable frame underneath have all been removed. We're going to just take the motor, put it on top of this, just in case it's too heavy to deal with. We can slide it down this 2x12 to a wood platform we have there at the bottom, just so that we have a nice landing zone for the motor. So if we have a hard time or difficult time moving the motor, I got some 2x4s right here, just to help me kind of position the motor to get it to where I want it to go and stuff like that. But basically this is the strong portion of the job. It's moving the motor from here to here and getting it out of the unit. Okay, so here's the old motor. It's a Century motor, and I'm going to just look at the data nameplate here, and it's a 230 460 volt motor, 7.5 horsepower. One other thing I'm going to be very noticing here is exactly the distance from the motor, the pulley is to the motor and the shaft and so forth, because I want to make sure that this lines up with the other end when I go to put the new motor in. We're going to go grab the new motor and do a side-by-side comparison, and then we're going to see if we can get this whole thing apart. In the meantime, I'm going to douse this with some WD-40 just to try to get this all nice and loose for me, so I can hopefully reuse this existing pulley. Otherwise, I got to buy a new one. Okay, I've got the new motor right here. I got the old motor right here. We're going to do a side-by-side comparison test to verify that that motor is compatible with this motor. First thing I'm going to look at is the frame. This frame is an F213 T as in Tom. This frame here, 213 T as in Tom. It doesn't have the letter F in front of it, but that may not be critical, so I'm not going to worry about that. Next is the voltage. This is a 230 460 volt motor on the old one, and the new one is 208-230 or 460. The amps on this one at 460 are 8.9 amps. The amps on this one here at 460 is 10.5 amps. So this one's actually going to be running a little bit more efficient than this motor here. The next thing I did, by the way, before I started doing this, I grabbed some WD-40 and soaked the hell out of this pulley bushing assembly so that we can try to get it off of this shaft. If we can, that'd be great. Now, another thing that I did was I took the motor shaft and I measured the diameter. Just take the shaft, measure the diameter like this, measures out at 1.25 inches. The distance from the motor to here is 3.5 inches. Take this one over here, the shaft is over here. Okay, look at that. Take my tape measure. You can see that that's 1.25 inches right there, so the diameter is the same. And then I'm just going to measure from the motor out to here. That's also 3.5 inches. So this shaft and this shaft are compatible shafts, so that's not a problem. Okay, now I want to make sure how this motor, this pulley is going to go on this motor. So I take the mounting bolt that mounts to the adjustable frame, the one closest to the shaft. I go in the center of that. Then I just take my magnetic torpedo level, bring it over here, and see where that comes down to my tape measure. It comes down to 6 3/4 inches. So if I get this off, or even if I buy another one, I'm going to do the same thing here so I can put it on, so I can put the pulley onto this motor shaft down here on the ground, because it's a lot easier for me to work here than it is inside of an air conditioning unit. So that's why I'm measuring this out. And then I just made a little note here. Okay, so I just make a crude drawing of the motor. These are the mounting bolts here. This is the shaft, and this is the pulley here. And then I just took a measurement from the center of that bolt to the edge of the pulley here, and I just wrote that down at 6 3/4 of an inch. When I go and transfer this onto the new motor, I'm going to look for that same distance. Okay, so here we are. I got everything doused down with some WD-40 to try to get this off. Got it on the front and the back side. This here is a 7/16 inch. We're going to go ahead and loosen those up right now. So I'll just take that, put it on here. Alright, it's not so bad. Okay, I got all three of the bolts out. I'm just going to take this and tap around. Okay, got that loose. That's good. That was the easy part. The hard part is taking this off of the shaft. Now there's a slit right there. What I can do is I can try to get that a little bit larger by my flat-bladed screwdriver. Let me grab that. Okay, so now I got my flat-bladed screwdriver. Down here I'm going to hold it like this towards the end of the circumference, and I'm going to try to tap that in there. Oh look, I got it. Did you see that? As I was tapping, this whole assembly started to move forward, but that's not the direction I want to go. I want to go that way. Let me just try my claw hammer here, see if I can get it. Give me a hard time. Alright. Let me try and open that up a little more. Hang on. This whole thing. Alright. Okay, so here we go. Just going to try to give myself a little bit of leverage here with a crowbar, but still this thing doesn't want to budge. I'm just going to work it a little bit more. I want to be somewhat gentle. This is just cast iron. I don't want to kill it. Alright, let me try it like this. Like this. Felt like it was going. It gave me a little bit there. Not as much as I want. I want that more. Wait. Got it there at the very end. Very close. I was getting a little aggravated just kind of working on it with that, so I got my pulley puller on here, but it looks like I'm going to have to adjust it from here to here because it looks like I'm almost at the end of the shaft. I only have a couple of threads. If it comes now, I'd be surprised. I'll work it just a little bit more. But this gives you the best leverage when you're trying to get something out. This really gives you the best leverage in order to do that. It's a slower process. It depends on how tight this is onto the shaft. But I'll get it with this tool. It's just going to be slow. So I'm just going to keep working this, and if I have to, I'll go ahead and grab another bite down there, but I'm just going to get this off the shaft. That's it. Alright, so one thing I want to note, I'm at the end here. I got to grab another bite, and I'm trying to go here to see if it'll just pop out. But one thing I got to be careful of when I do this, when this is sticking on here, it's very easy to break this cast iron pulley right here. Right there, it's very easy to break that. So if you don't want to break that, you're safer off using this tool right here. And that's it. Alright, so anyways, I almost got the whole thing out. There it is. I think I got it right there. But the more that I've been considering this and how difficult the new motor is going to be to put in, I decided I'm just going to buy a new pulley anyways. So this is really just for the video to show you how to take it off the shaft. Once I got it to this point, there it is right there. I got it off. I'm a little disturbed about inside here. It's kind of rusty. I don't know. I mean, how old that motor is, but it's so old the thing's seized up. So rather than take any chances, I'm just going to go ahead and grab a new one of these pulleys and a bushing right here. Once you put these all together and you put the bolts in and you tighten it down, that's what locks it onto the shaft. And then of course there's a keyway here that keeps it to turning the shaft. That's how the whole thing works. But I'm just going to go ahead and purchase another one of these. When you go buy another one of these, what you're interested in is what belts go inside here, A belts or B belts. So I'll look at the belts. And then this is 3 pulleys, three V belts. And then I'll need to also specify the shaft diameter and the diameter of this right here. So I'll just write all this stuff down to make sure I get the exact same pulley at the store. I'll probably get this at Granger's because certainly can't get that at the Home Depot. So that's it for now. Okay, welcome back to our installing this motor project. We took a holiday off because of the Christmas and New Year holidays, so we're back to this motor. We want to get this thing installed. Got our brand new motor. I got a brand new pulley and shiv, bushing. This here's the bushing. This here's the shiv that's going to go onto this shaft. Now, if you remember, I took a measurement off of the old one before I left, and it was 6 3/4 of an inch from the center of this to the edge of this. So I'm going to be measuring with my tape measure like this, 6 3/4. So the first, when you're looking at the shiv, okay, you'll notice that what you've got here is three areas that have threads in them and 3 areas that do not have the threads. When you're looking at the bushing, okay, let me put this down. The bushing has got 3 threaded areas and 3 areas that do not have any threads. And what you want to do when you put this together, you're going to take the non-threaded area on the bushing, line that up with the threaded area on the shiv. Just give me a second to line that up. Okay, just like that. That way all 3 are all lined up. Now there's already some oil that's already on these these bolts here, but I brought a little bit of never sees. I can give them a tab and never sees, so I can just put a little tab on there and put that through. Now, what I'm going to do is I'm just going to start this off. But basically, when I go and tighten this on, it's going to tighten the bushing to the sheave on the shaft, and it's going to do that very tightly. When you want to go to take it off, what you do is you come out of that hole and you go in the threaded hole here, all 3 of your screws, and when you tighten that down, it pushes the bushing out of the sheave, breaking that bond. So that's how this works, okay? So I'm just gonna get these screws on here and get this set up so we can put this on the shaft. Okay, I got these just close to finger tight. So in other words, it's very, very loose. I'm gonna come over here onto my shaft. I'm just gonna put a little bit of never sees, anti-seize on the shaft, just to give it a little bit of protection there. So this way, if I ever want to take this apart years down the road, it'll be a little bit easier for me. Okay, now what I'll do is I'll put the shaft, the keyway kind of facing up. I've got a keyway that's got to mate with that keyway. Okay, now you see how well that slides? This is the entire reason why one of the reasons why I wanted to go brand new. Because now I can sit here and put this wherever I wanted to, and I'm not going to have any issues. Plus, I wanted to start out with brand new grooves on the sheave because I wanted the belt to sit in here appropriately. I didn't want to go through all this work for nothing. Now, I already know that I need 6 3/4 of an inch from here to there. So I can see on my tape measure, I am just about there. The pulley is out just about a 1/16 of an inch that way. So I'm going to grab my socket, I'm going to start tightening this up, and I'm going to see if that pulls in. It might pull this back a little bit. Maybe I'll just give that just a slight tap. Measure that out. Okay, so right there is actually 6 3/4. Let me tighten this up and let's just see where we land. Okay, so I have my 7/16 inch wrench here, and I just tighten these up, not tight, super tight, just snug. Then I'm measuring out like this, and I'm a little bit over 6 3/4, so I'm just going to gently tap all the way around there, and that's good. That brings me to actually just shy of 6 3/4, which is not bad. I'm going to go ahead and tighten this up now some more. When you tighten it up, you want to kind of go around even. You don't want to just tighten one up. You want to bring them all in equally. Let me measure that again now that I'm a little bit tighter. Okay, that's good. It's right at 6 3/4. So apparently when you tighten this up a little bit, it brings the sheave just slightly out. Not much, but just slightly out. Okay, we're pretty much tight. All 3 of these are tight. I'm going to stop. I'm going to take my straight edge here, and we're going to give you a close-up here of the tape measure. And you see that? Just a little bit of a hair of about a 1/16 over on 6 3/4. It's very, very, very close to 6 3/4. Mind you, this here is V-belt pulleys. There should be a little bit of leeway there. So I'm going to consider this in the appropriate location. And that's how I want to get this done while I'm down here on the ground, because it's easier for me to work here than it is inside of the air conditioning unit. All right, now we're going to go over the electrical. This here is the data nameplate for the motor. Now if you look here on the schematic that the manufacturer, this Dayton manufacturer gives you, it tells you that there is two voltages, low voltage and high voltage. Now when you come over here and you look at the volts, you'll see that this motor is capable of 208-230 or 460 volts. Well, we're using 460 volts, so we need to look at the high, because it's the high voltage according to the manufacturer. Okay, so we're going to use the high voltage because that's our voltage that this motor is going to get fed from. So there are three lines. When the electricity that comes in through this grommet hole is going to be four lines, L1, 2, and 3, and a ground. Well, the ground is easy. It just goes to a ground screw inside here. And L1, 2, and 3 are going to go to 1, 2, and 3 right here. Now, the other wires, I need to hardwire 4 and 7, 5 and 8, and 6 and 9 together. So if you look at the wires here, it tells you, as an example, this wire here is T9. So if I look at T9, I know that T9's got to go to T6. So now I need to find wire T6. Here it is. For some reason it's a blue color one. Okay, so now what I need to do is I need to wire nut together 9 and 6. And so I'm just going to go ahead and make that connection right there. Alright, so I'm back here. I've got wire T9 and T6. Check my schematic. That's what I want to do for high voltage. I'm going to put those two together and connect them up with this wire nut. The manufacturer gave me a little bit of extra material here, so I'm just going to cut some of that off. Actually, that's not working for me. Let me try a yellow. There we go. Whenever I do a connection like this, I always try to pull the wires out of the wire nut. That's totally solid. So I'm just going to go ahead, find the other wires, which are 4 and 7, 5 and 8, and do the same thing. Alright, so I've got the wire nuts on the 6 wires for the high voltage on the schematic that I needed to get done. All that's left that's unterminated here is T1, 2, and 3. So I'll take care of 1, 2, and 3 once we bring the electrical in, once the motor is in the unit. Okay, so what I'm doing is I'm prepping out to put the motor actually in the unit. These here is where the motor is going to sit on this block here, which allows you to move the motor back and forth. So I put a little bit of anti-seize on the 4 screws that hold that in. Just kind of comes up like that once it actually goes down. Another thing I did is I took some emery cloth and I went through the pulley here on the existing fan shaft, and I just kind of sanded that down because there was a little bit of surface rust on there. Another thing that I did was I looked at the bearings. Since the motor's not in here, I looked at the fan shaft bearings and they looked like they needed to be serviced and greased. So I went ahead and serviced the bearings on the shaft. There's no return fan on this unit, so we would have serviced that one at the same time. Just because I want to get this all perfect while I got it all opened up. So the next step is for us to actually get the motor into the unit. All right, so I kind of built this for moving compressors. but you can use it for this motor here too. So what I did is I've just simply got a rope here attached to a 2x4, and I've got a shackle on there. So what I'll do is I'll bring it out like this, take a couple of guys, and once we pick that up, we can pick that up like that a little bit easier with two people, one guy on one side, one guy on the other. So we'll just get it as close as possible using this technique for now. And then once I had it landed inside the bolts where the mounting bolts, so that you could do the motor adjustment, I was able to see if the two shivs lined up, and they don't line up. But I'm going to show you how I tested that out. Now I don't have two shivs here. I just have the one old shiv that came off the motor. So you got to kind of pretend that this here is a shiv, and let's just say that this is the motor operating this shiv, and this shiv is the fan shaft. So what you do is you take some string like this and you bring it down to where it just touches one side of the shiv and the other side of the shiv, and then you see how the second shiv lines up with that. Now when you do it this way, if the camera is catching this, you'll see that I'm off by about, I don't know, 1/8 of an inch or so. So that's exactly how much I'm off inside of this unit. I'm off by 1/8 of an inch. So rather than bring the motor out and make an adjustment inside the unit, I'm just going to lift the motor up, turn it, and then I'm going to shrink that down. Now if you remember, when I did the original measurement, I wrote it down here, I was at 6 3/4, so it'll be 6 5/8, because I want to go 1/8 of an inch closer towards the motor. Is what I want that the motor pulley to be pulled up, so I can line that up. So we're going to go off camera right now and line it up. All right, now I've got the motor turned to the side so I can work here on the shiv and the bushing. Now that I can do that, rather than measure from the center of that bolt to the edge here, it's a lot easier for me to measure from the motor right to the shiv. So now I'm going to take that measurement right at the top of the shiv, and you'll see that that's 1 1/8 of an inch. So I'm going to loosen up the bolts, and I'm going to shrink that down to 1 inch to make it 1/8 of an inch shorter. So that's what we're going to work on right now. Okay, so I had to break the entire bond by taking the 3 bolts out, moving them over on the bushing, and then I broke it. So now you can see that I can completely move this whole deal. It's like starting over from scratch. But I've got a really solid measurement, and I know that I want 1 inch. So this way I'm going to take this, I'm going to bring it to just shy of an inch, because I believe it's going to move a little bit while I do it. And I'll see if that sucks right into 1 inch while I do it. So I'm going to start tightening up with my wrench right here. just keep getting some measurements here as I do it. Alright, we got the motor in, the shivs are lined up close enough. I'm going to put the V-belts on, get ready just to adjust the motor and tighten everything down and then do the electrical. The V-belts, when you put the V-belts in, I like to put the V-belts in so that when you're viewing the belts, you can read them. So rather than install them this way, since I'm going to be the one to put them in right now, I'll put them in like this. So this way they can be easily read at the same time. And I'll put them all in like this, so that they're all kind of close to one another and so forth, and they're just easy to read. Alright, so I'm going to go ahead and do that right now. Okay, so what I've done is I've adjusted the motor using this bolt right here, and when you loosen this bolt, it pushes the motor that way. Now you see the tension that I've got here on my belts. I actually didn't buy 3 new belts. The belts, these are a cog belt here. You can see the cogs in them. They actually look like they're in good condition, so I'm going to reuse them. And now I got the adjustment where this one's a little taut. The other 2 are kind of loose. So I've got like that much deflection going back and forth. I'm going to go ahead now that the motor's where I want it. I'm just going to go ahead and tighten up the 4 bolts like this. So there's 2 here and 2 on the other side that actually mount the motor to the adjustable base. So I'm going to go ahead and do that right now, and then the electrical. Okay, so in the process of tightening up the motor bolts, I was just starting the first 2 here. I checked my tension again, and that's too tight now. I don't want it that tight. So what I'm going to do is I'm going to loosen up these ones here so I can slide the motor back and forth. And I'm going to take my wrench and go from loosen to tighten, and I'm going to slightly move the motor. There we go. About that much. Then I'm going to then I'll check to see how loose that is. And now I'm going to go ahead and tighten that up here and see if I like my belt tension, what that looks like. Once everything is fully mounted, I don't want too much tension. I want to get the right deflection, the right tension on the V-belts. That's actually where I want it. So I'll grab the ones on the back side now and make sure that I'm still maintaining that same tension. Alright, so this is my electrical flex connection that's going to go in the bottom of where the electrical feeds into the motor. You'll see I've got 3 lines here: yellow, brown, and orange and green. Obviously the green one is going to be for the ground, and the other ones are terminals 1, 2, and 3. And I wrote down, when I was disconnecting the motor, I wrote down what terminals came off of what, off the old motor. Number 1 was brown, 2 was orange, and 3 was yellow. So when I first start up, just to see if I got the right rotation, I'll actually do the same way. Now, this half-inch opening knockout here, on the motor it's much larger, so we have to use these plates. These plates have a dimple in them, so this way what you want to do is you want the dimple to go towards the plate. So in other words, you've got the electrical connection. I got the dimple on that one facing up. So I'm going to put that down like this, put that one through the motor, and then on this one, which by the way, these are 1.5 inch. Then on this one, I'll put this down, and then the lock washer to secure this to the motor. And then I'm just going to connect terminals 1, 2, and 3 together, wire nut them, and then we'll do a rotational check to see how we're doing on the rotation. Alright, I got my electrical feeding into the motor here, but the copper is kind of old. The existing copper that's in here is kind of old. So I'm just taking some emery cloth, and I'm just trying to shine that, bring that shine back and get rid of the, I don't know, oxidation or whatever you want to call it that's on top of the conductor, the copper conductor. So I'm just going to kind of clean these off a little bit before I do my wire nut connections. so that way it's got the best electrical connection possible. So I just wanted to show you that real quick. All right, we got our motor started up. When we first started it up, the rotation was going in the opposite direction, which in this case was clockwise. We shut it off. We changed 2 of the 3 phases in order to get the motor to spin in the opposite direction counterclockwise. The service factor amps on this motor at 460 volts is 10.3 amps. We're pulling about 7 amps right now. I'm going to go ahead and show you the motor inside here. There it is right there. The belt, one of the belts looks a little wobbly, but there's no real vibration going on here. All in all, this looks fine. I still got my electrical leads hanging out the side of the motor, so I got to shut it down one more time, just so I can put the electrical leads back in the terminal housing. But pretty much, all right, so that's the end of this job. Happy with our motor installation. All we got to do now is just clean up our tools and skedaddle out of here and on to the next project. If you like the video, go ahead and click on like. If you want to check out more of my videos, go to Ken Training on YouTube. And that's it. I'll see you later.